Hello everyone, welcome to our YouTube channel GurMantra Shiksha Ka Granth. I hope you all are doing good, you all are fit and fine, your studies are also going in a smooth manner. I am your educator Nidhi Dua and I teach you chemistry here. This is your chemistry syllabus for GATE 2021. We have started section 1 named Atomic Structure. In the previous lectures, we have completed these topics, and in this lecture, I am going to explain you about the quantum numbers. To understand what is quantum numbers or what are quantum numbers, let's take an example. If you want to know the particular address of a particular person, you need four things. The number one, the country to which the person belongs. Number two, the city in that country where the person is residing. Number three, the particular area in that particular city. And number four, house number of that person in a particular area. Similarly, to locate the position of an electron, to find the address of an electron in the atom, four identification numbers are required. And these identification numbers are called as quantum numbers. Or we can say a quantum number is a value that is used when describing the energy levels available to atoms and molecules. The value of conserved quantities of a quantum system are given by quantum number. The set of number used to describe the position and energy of the electron. There are four types of quantum numbers. Number one is principal quantum number, which gives information about the shell, the particular shell to which the electron belongs. Number two is azimuthal quantum number, which gives information about the subshell of an electron. Magnetic quantum number gives information about the orbital, and spin quantum number gives the information about spin of an electron. Let's take a brief about all these quantum numbers. As you know, number one quantum number is principal quantum number. This is represented by small n, and this principal quantum number was given by Niels Bohr. Principal quantum number represents the named size and energy of the shell to which an electron belongs. The value of n could be in between 1 to infinite. It cannot be in a fractional value, it cannot be in a decimal value. It must be in a whole value. As the value of n increases, as the value of principal quantum number n increases, the distance of an electron from the nucleus also increases. This can be confirmed by the following result. As you know, the formula of radius is equals to 0.529 into n square by z. By this formula, as you can see, r is radius r, which means distance is directly proportional to n square. Therefore, as the value of n increases, distance of electron from the nucleus also increases. Next is, as the value of n increases, the energy of shell also increases. As you know, principal quantum number gives us the information about the particular shell of the electron, and E is equals to minus 13.6 into Z square by N square electrovolt per atom. As you can clearly see, energy is inversely proportional to minus of 1 upon N square, which means as the value of N increases, energy also increases. This is very important to note that there is a negative sign in front of 1 upon n square, which changes its result. The number of an electron present in a particular shell is 2n square. Means if we want to calculate the number of electrons in a shell, it can be calculated by the formula 2n square. You have to simply put the value of n, the value of principal quantum number in this formula, and you will get the result. Next quantum number is azimuthal quantum number, which is represented by L. This L was given by Sommerfeld, and azimuthal quantum number is a quantum number for an atomic orbital that determines its orbital angular momentum and describes the shape and orbital. The value of L lies between 0 to n minus 1, which means the value of L can be in between 0 to n minus 1. For S subshell, the value of L is 0. For P subshell, the value of L is equals to 1. For D subshell, the value of L is equals to 2. And for F subshell, it should be 3. You can calculate the value of L by simply n minus 1. If the energy of n is same, then the order of energy of various subshell will be S lesser than P lesser than D lesser than F. Which means if you are given the principal quantum number value same and only the subshells are different, you can give the order in the following. As you can see here, the principal quantum number is same but the subshells are different. You can simply give the order in this manner. The orbital angular momentum can be calculated by this formula, that is under root of L bracket L plus 1 into h upon 2 pi. You have to remember all these formulas because they may asked directly in the numerical problems. And if you want to calculate the number of electron in a particular subshell, this can be calculated by this formula, that is 2 into 2L plus 1. Also, as you know, if you want to calculate the number of electron in a particular shell, which is equals to 2n square, and to calculate the number of electron in a particular subshell is equals to 2 into 2L plus 1. As you know, azimuthal quantum number tells us about the shape of subshell. The shape of different subshells are: S is spherical shape, P subshell is of dumbbell shape, D subshell is of double dumbbell shape, while F subshell is of complex shape. Next quantum number is magnetic quantum number. This magnetic quantum number is represented by small m and it was given by the scientist Lind. Magnetic quantum number specifies the orientation in space of an orbital of a given energy. Also, magnetic quantum number tells us about the orbital. This number divides the subshell into individual orbitals. The value of m lies between minus L to plus L. For example, if you have given the value of L is equals to 1, so the value of m will be minus 1, 0 and 1, which means the value of L has 3 orbital, and L, as you know, L is equals to 1 is for p orbital, which means p subshell has 3 orbitals. Now there are 3 cases for magnetic quantum number. Number 1 case is if the value of L is equals to 0, then the value of m is equals to 0, which means, as you know, value of m lies between minus L to plus L. If the value of L is given 0, the value of m should be 0. It implies that the subshell is S, because you know that value of L is equals to 0 for S subshell, and S subshell has only one orbital called S orbital. The size and energy of s orbital also increases as the principal quantum number increases, as you can see here. 1s lesser than 2s lesser than 3s. The energy is being increasing from left to right. Case 2 is if the value of L is equals to 1. You know it very well. L is equals to 1 for p subshell. And p subshell has 3 orbitals, commonly referred to as px, py and pz. These 3 orbitals px, py and pz possesses equivalent energy, means they have equal energy. This px, py and pz has equal energy. They only differs in their direction and distribution of charge. This is very important to note that the value of m is equals to 0 for pz. The value of m can be plus 1 or can be minus 1 for px and py orbital. And for p orbital, the value of m can be in between, could be in between minus 1, 0 and plus 1. For pz, it should be 0, or for px and py, it should be plus 1 or minus 1. Now this is very important to note that each p subshell has dump bell shape. Each p subshell has dump bell shape and 2 lobes. As you have seen here, each p subshell has dump bell shape and 2 lobes. 2 lobes are separated from each other by a point of 0 probability. 0 probability means where there is a probability of 0 to find an electron, and this 0 probability region is known as nodal point, node or nucleus. The 2 lobes of each orbital are separated by a plane of 0 electron density. These 2 lobes of each orbital has a probability of 0 electron density called nodal plane. This is the nodal plane where you cannot find any electron. To calculate the nodal surface, you need the orbital. And to calculate the nodal surface, the formula is quite simple, that is n minus 2. For example, if you have given 2px orbital and you have to calculate the value of nodal surface, you can simply calculate it by putting the value of principal quantum number in the formula. As you will put the value 2 minus 2, you will get the result as 0, which means 2px orbital has 0 nodal surface. Case 3rd is when the value of L is equals to 2. You know it very well, the value of L is equals to 2 for D subshell, and M has 5 values, means M has 5 values because the value of M lies between minus L to plus L, and if the value of L is equals to 2, then the value of M should be minus 2, minus 1, 0, plus 1 and plus 2. It implies that D subshell of any energy shell has 5 orbitals. These are the 5 orbitals. These 5 values of M tells us about the 5 orbital of D subshell, and this value L is equals to 2 tells us about the D subshell. All the 5 orbitals are not identical in shapes. 4 of the D orbital, dxy, dyz, dxz and dx square minus y square contains 4 lobes, while the 5th orbital, dz square, consists of only 2 lobes. You have to remember this. The 5th orbital, that is dz square, this is very important, has only 2 lobes, while rest of the orbitals are having 4 lobes. Now, as you know, the value of M for the D subshell can be minus 2, minus 1, 0, plus 1 or plus 2. So you have to remember this. The value of M is equals to 0 for dz square orbital. This is very important. Question have been asked directly. The value of M for dz square orbital is. So the value of m is equals to 0 for dz square. The value of m could be plus 1 or minus 1 for dyz and dxz. The value of m could be plus 2 or minus 2 for dxy and dx square minus y square. Here I would suggest please note all the formulas and learn them quickly. Now if you want to calculate the nodal surface where L is equals to 2 or for D subshell, you can calculate it by the simple formula by putting the value of n principal quantum number subtracted by minus 3. You can also calculate the nodal plane. You have to remember these, but the very important is dz square, which have 0 nodal plane, which do not have any nodal plane. Next quantum number is spin quantum number, represented by the letter S. It was given by Goldsmith. This quantum number represents the direction of electron spin around its own axis. And the spin quantum number can be clockwise spin or in the anti-clockwise spin. Spin for the clockwise spin, the electrons are known as or represented as spin up quantum number, which have the value plus half. And for the anti-clockwise spin, the electron is known as spin down electron, and this has the value minus half. You can simply calculate the spin quantum number or spin angular momentum number of an electron by this formula. The formula is under root of s plus 1 dot h upon 2 pi. This is very important to note that an electron has a plus half spin or minus half spin. It could be in a up spin or in a down spin. I hope you guys are now cleared about these set of quantum numbers. Now let's have some questions on these quantum numbers. So number 1 practice question is, for 7py calculate the value of n and l. You have given 7py and you have to calculate the value of n and l. Here I would suggest please pause your video and solve it quickly by yourself. I am giving you some time. Okay, let's see the solution. You have given 7py and calculate the value of n and l. As you can see here, the value of n can be directly seen, that is 7. And for p orbital, the value of l should be 1. For p subshell, the value of l should be 1. As you can see, the value of n is 7 and the value of L is plus 1. Next question is, for 3s, calculate the value of N, L, M and S. You have given 3s and you have to calculate all the values of all the quantum numbers. Please do it quickly. Okay guys, let's see the solution. You have given 3s and you have been asked about all the quantum number. So as you can clearly see, the value of n is 3 and the value of L for S subshell is 0. If the value of L is 0, the value of M should be 0 because you know it well, the value of M lies between minus L to plus L. If the value of L is 0, then M should be 0. And for spin quantum number, it could be plus half or minus half. As you can see here, the value of n is 3. The value of L is equals to 0 for S subshell, and for S subshell for the value of L, the value of M is also 0, and for S subshell, for spin quantum number S, it should be plus half or minus half. I hope you are cleared now. Next question is, for 5dz square, calculate the value of n, L, M and S. Now you have given 5dz square and you have to tell all the quantum numbers, about all the quantum numbers. Please solve it quickly. Okay, let's see the solution for this question. As you have given 5dz square, which means the value of n should be 5. And as this is d subshell, this is given the d orbital, then you know the value of L for d subshell is 2. If the value of L is 2, the value of M should be in between minus 2 to plus 2. So, and also in the previous slide, you have understand the value of M should be 0 for dz square. I have already told you the value of M is 0 for dz square, and this is very important. And for S spin quantum number, the value can be plus half or minus half. So as you can see, the value of n is 5, L is 2, M is 0 for dz square. You have to remember this, for dz square M is equals to 0. And for S spin number, that is plus half or minus half. I hope you guys are now cleared about about all the quantum numbers. We have seen the theory and we have practiced about all the questions. In case you are new here on this YouTube channel, GurMantra Shiksha Ka Granth, you can do like, share and subscribe. You can also join our Telegram channel for more new updates and for notes, for PDFs. You can also join our Facebook page, that is GurMantra Shiksha Ka Granth. For further queries, please mail us on tanejanehaofficial@gmail.com, or you can contact us on the given number